Assalamu alaikum students and welcome to another lecture of Slate. This is Sir Yasin. Let's study chemistry. In the last lecture, we talked about the electronic configuration of different elements ranging from atomic number 1 to 20. And then we also discussed the transition elements, though we will study that in A2. But still, this very concept, the one we studied in the last lecture and the one we are going to study today, that is still applicable in the AS chemistry. So, when we talk about transition elements, there was one unusual property. We will come back to that later. But then, after that we have done the electronic configurations. Now let's see, what do we have in addition to that? We have ions here. What was an ion? An ion was a charged particle formed by gaining or losing electrons. It's a charged particle which is formed by gaining or losing electrons. That is an ion. But why do atoms make ions? That's a very important part. Why do atoms make ions? Now, atoms make ions to attain. We will discuss that in like 2 minutes. To attain the electronic configuration of the nearest noble gas. So they make ions to attain the electronic configuration of the nearest noble gas. Nearest is important there. Because let's talk about one of the first few 20 elements. For instance, we have sodium. What was the electronic configuration? 1s2, 2s2, 2p6, 3s1. And before sodium, we had argon, a neon. 1s2, 2s2, 2p6, and that's it. So that was the electronic configuration of neon. Let's talk about magnesium there as well. And for a moment, let's talk about argon as well, which is in the same period as of sodium and magnesium. But when we talk about argon, argon is 1s2, 2s2, 2p6, 3s2, 3p6. Now, if we add, one example is fluorine as well. 1s2, 2s2, 2p5. Now we know, since fluorine is in group 7, it makes a fluoride ion, F-. That is something we know about. But how does it make F-? By gaining one electron. So when we gain electron in this electronic configuration, this would be 1s2, 2s2, 2p6. Now this is the exact configuration of neon. What about sodium? It loses one electron, Na+. So this electron is lost. So this becomes 1s2, 2s2, 2p6. Again, neon. Magnesium. 1s2, 2s2, it loses 2 electrons to make Mg+2. 2p6. Again, we are getting the electronic configuration of the nearest noble gas. Although argon is in the same group, but who is going to imitate argon? The elements close to argon. For instance, chlorine. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5, group 7, and it makes a chloride ion. And what happens in a chloride ion? We gain one electron. 1s2, 2s2, 2p6, 3s2, 3p5. The same electronic configuration as that of argon. Even if we talk about calcium, which is after argon, so that again would make 1s2, 2s2, 2p6, 3s2, 3p6, and the last one will be 4s2. But if we lose these two electrons and we make it a calcium ion, so what would be the electronic configuration of calcium ion? Loses two electrons, these two electrons will be gone, and again, the electronic configuration of the nearest noble gas, argon. So this is simple with S and P block elements. But let's talk about D block elements. For example, right after calcium, we get scandium, 21. So it was 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. This is something we do remember. Now, an important concept here. Remember what did we study about transition elements? I will write it right here. In transition elements, electrons are added in 4s first as it has lower energy than 3d. We knew that. But normally the case is the one which is filled later loses the electron first, right? Like here we had 4s, it was filled later and it lost the electrons first. Here we had 3s, it lost the electrons. But while losing electrons, 4s loses electrons first. Always, that is the rule because it is the outermost shell. 3d is the lesser one, 4 is the outermost. So outermost loses it first. So since all of them have 4s2, they all make +2 among other oxidation states. Among other ones. यानी कि इसके अलावा और भी हैं. There are more oxidation states as well. O levels, transition elements, variable oxidation state. Now why is that so? Because of this very rule. अगर हम इसकी बात करते हैं, if we talk about scandium here, scandium will make a +2, but how? 1s2, 2s2, 2p6, 3s2, 3p6, 3d1. This is scandium 2. But what if? Let's talk about some other element. We can also remove the d1s as well, right? Because why do atoms make ions? To attain the electronic configuration of the nearest noble gas. Titanium is a better example. When we talk about titanium, titanium has this electronic configuration. So titanium can make two different ions, two different stable ions, that I would say. One is titanium +2. Obviously, how will that be? By losing just the 4s2. We lost 2 electrons. But then, titanium can also make a +4 by losing these d electrons as well. So in this case, titanium becomes +4. So you will lose the 4s first and then you will lose 3D again. Most common example, iron. If we talk about iron, (3D6), that is the electronic configuration of iron. So first, we know it is going to lose 4s2, obviously. So if we lose 4s2, what do we get? We just get an iron plus 2. That is what we get here, easily. But how do we get iron plus 3? Remember, half subshell is stable. So iron will swiftly lose one more electron from D to make it a half-filled subshell, 3D5. So that is why Fe3. Manganese. Manganese also have variable oxidation states, +2, +4, +7. But the major ones are +2. So if we talk about Mn +2, again, you know what's going to happen. We just lose the 4s2 here, not the 3D. But then again, one of the most important oxidation state of manganese is Mn +7, purple in color, KMnO4. So for that, we will lose these 5 electrons as well. And hence, we are going to get this electronic configuration, students. This one. And this is the electronic configuration of the nearest noble gas. So they can attain different states. First, by losing the 4s. Then, by losing the 3D ones to attain the electronic configuration of the nearest noble gas. Iron can also lose 5 more electrons. But then that's not stable. That is the concept of stability constant in A2. So for now, all you need to know is that 2 electrons are removed from 4s first in the case of transition elements. And they can further lose electrons, but then from the D. Obviously, we cannot remove electrons from this configuration anymore. Why is that so? We cannot remove electrons after 3p6 just because that is the configuration of the nearest noble gas. That is why we cannot remove any further electron. So that is all for this concept of ions and their electronic configuration. So thank you so much for being here with me. Take care and Allah Hafiz.